Number 3, Tiffany posts a story on her Instagram at 9 a.m. The rate that her followers view her story is modeled with selected values in these tables. And t equals 0 represents 9 a.m. The rate is measured in people per hour. We're going to use the data in these tables to approximate the following. So in A, it asks us for a right Riemann sum with 3 subintervals, and we want to approximate the integral from 0 to 5, p prime of t dt. And it does ask us to include units of measure in our answer, and then we're looking for what this means in terms of the context of the problem. So we'll have to include quite a bit here. So first of all, we're going to want to write out our integral from 0 to 5, p prime of t dt is approximately equal to, just to be clear what we're actually approximating. When I look at my table, we're going from 0 to 5, and it tells me 3 subintervals. So we're just going to use the subintervals that are dictated by the table. So from 0 to 2 is one, from 2 to 4 is another, and 4 to 5. That gives me my 3 subintervals. But what you might notice about those subintervals is they are not evenly split up. This is often the case with tabular problems like this. So my first width is 2, from 2 to 4 is 2 again, but from 4 to 5 my width is 1. And so what that means is we cannot factor out our delta x in the front like we did before. So my first rectangle, remember these are rectangles, my delta x is my base, and then my y values are my height. So these are my bases up here, then I'm going to go down for my height. So my first rectangle, I use the height on the right. So my first rectangle will have a base of 2, a height of 30. The second rectangle will also have a base of 2, but my height will be 54. And my last rectangle will have a width of 1 and a height of 26. So if I add that up, again, you don't have to do that on the AP test, but you do want to make sure to show that step. We would get 194. My units would be people. So when I integrate people per hour, I'm doing people per hour. That was these units here, people per hour. And then I'm multiplying it by hours. So the hours cancel out and I just get people. That can help you determine what this actually means. So this means $194 people viewed Tiffany's story. Now you can say from t equals 0 to t equals 5, but let's actually think about what it means in terms of the problem. It told us that t equals 0 represents 9 a.m. So that means from 9 a.m. to 5 hours later, from 0 to 5, that would be 2 p.m. Notice here that when we're doing integrals, our interval, we're going to have a time interval there as opposed to a single time like we did with derivatives. Okay, part B. Now we're going to use a left Riemann sum with 4 subintervals, and we're going from 4 to 12. So pay attention that we're going from 4 to 12. And I will use the 4 subintervals as dictated by the table. So from 4 to 5, 5 to 6, 6 to 9, and 9 to 12. So I'm approximating my integral from 4 to 12. Because I'm using a left sum, I will use my left endpoints here. So from 4 to 5, my width is 1. The height I'm going to use is the one on the left, that's 54. So 1 times my height, 54, plus from 5 to 6 is 1 times my height is 26. From 6 to 9 is 3 times 21, plus from 9 to 12 is 3 as well, times 44. And then as long as I put units at the end here, this would be an okay answer on the AP test. Once again, I want to emphasize here, it's super important that you show a sum of products like we have here, a sum of products. So we're showing that we're doing the area there. And this is an okay way to leave your answer. Part C, it asks us to find a midpoint Riemann sum with 3 subintervals. And we're going from 0 to 12. So all the way from 0 to 12. And it says 3 subintervals. Now again, don't worry about these being split up evenly. We have to split them up though so that we have a middle point. So from 0 to 4, my middle point is 2. From 4 to 6, my middle point is 5. From 6 to 12, my middle point is 9. So my integral from 0 to 12 is approximately, so let's see, my first width from 0 to 4 is 4. Then I'm going to use the middle point as my height, 30. Plus my base is 4 to 6, that's 2. My height will be 26, my middle point. From 6 to 12, my width is 6, and I will use times 44. And so that will give me 436 people. Now we don't want to actually compare these answers that we got in A, B, C, or D together because they're all approximating different integrals using different methods. But definitely since they're different intervals, it will be hard to compare them to one another. The last one we're going to do is a trapezoidal sum, which is usually the most complex. We're going from 0 to 12 again with 3 subintervals. So again, we start out, just split it up in 3 subintervals like we did before. So 0 to 4, 4 to 6 is 2, and then 6 to 12 is 6. What will be different though is that we have to do a trapezoid area for each interval. So remember that formula once again is 1/2 base 1 plus base 2 times your height. You can put the height at the front if you want. So plus 1/2 times, I'm going to go ahead and do my height first, 4. My base 1 and base 2, I'm going to use both of my endpoints, 41 and 54. Plus 1/2, my width is 2, my delta x, times both of the heights, 54 plus 21. Plus 1/2 times 6 times 21 plus 11. So again, you're adding your endpoints of your interval, multiplying it by the width of the interval times 1/2. That will give me 361 people. Sometimes instead of a table of values, you'll be given an equation instead. So here we're given f of x equals x squared. We want to find a midpoint Riemann sum for the integral from 1 to 3 of x squared dx. I think it's helpful to actually sketch out what my interval would be first. Or actually even before that, let's figure out, I forgot to highlight something. We have 4 subintervals of equal length. So the equal length is important there as well. So we want to find our delta x first. So we do b minus a, 3 minus 1, divided by 4, because we want to use 4 subintervals. So we've got 2 over 4, which is 1/2. That will be the width of our interval. And so I'm going to sketch this out to kind of think about it. I know I'm going from 1 to 3. I want to split it up into 4 subintervals. So I'm going to split it up from 1 to 1.5, 1.5 to 2, 2.2 to 2.5, and 2.5 to 3. But because I'm doing a midpoint sum, I will use the y values at the x values halfway in between. So I'm going to use the y value at 1.25, at 1.75, at 2.25, and 2.75. So these other numbers are just the endpoints of my intervals, but they're not going to be the heights that I actually use. So for my integral, I can factor out my 1/2. I know I'm going to have to do f of 1.25 for my first height, f of 1.75, plus f of 2.25, plus f of 2.75. And so I just have to figure out what those y values actually are now. And so what I can do is plug it into my f of x, which is x squared. So you might have some other function. You're just going to have to evaluate the function at that x value. And so if I actually calculate this, which I think you'll have to do on Delta Math, you will get 8.625. But just pay attention to this step right here. You're evaluating whatever your function is at those points. As we said before, we will often want to know if our approximation is an underestimate or an overestimate. So if you pay attention to these two graphs on the left, this graph is a decreasing graph. And what we'll notice is a right-hand sum is a under approximation, a left-hand sum is an over approximation. If I flipped it around though and had an increasing graph, that would switch. So for left-hand rectangles, it's an overestimate if our graph is decreasing. In other words, if our graph is decreasing, then our left point is greater than our right point, so it would be an overestimate. And it's an underestimate if f is increasing. That flips around for right-hand rectangles. Since midpoint rectangles are usually under and over the graph at the same time, we actually cannot determine if they are an underestimate or an overestimate based on the graphical features. And for trapezoids, what we'll notice here, you can see this graph is, these trapezoids are under approximating the curve, and that's because this curve is concave down. If my graph were concave up instead and I tried to draw a trapezoid on this interval, it would actually be an overestimate. So for left and right, you pay attention to increasing, decreasing. For trapezoid, pay attention to concavity. And again, if you can't remember those, just try to sketch out a graph of whatever information is given and see if you can figure it out. So for example, in number 5, the depth of water in tank A in inches is modeled by a differentiable and increasing function. So I bet it's going to be important that that says increasing. For the interval from 0 to 10, h of t is given in the table. We want to approximate the integral from 0 to 10 of h of t using a right Riemann sum with the 4 subintervals indicated by the data in the table. And then it asks us, is it greater than or less than our integral, which is really saying, is it an overestimate or an underestimate? So we'll figure all of that out. So let's do our approximation first. So we are going from 0 to 10. We will use all of the values in this table. So from 0 to 2, and then we are going to use a right Riemann sum, so we'll use the right heights. My first width is 2, my base, times my height, 10. Sorry, I should use approximately equals there, not equal sign, plus from 2 to 5 is 3 times 15.5 plus from 5 to 7 is 18.5, sorry, is 2 times 18.5 plus from 7 to 10 is 3 times 20. And again, this is where you want to leave your answer. I just want units on it. It could actually ask me to figure out what that means. Oh wait, actually, don't worry about the units on that. It doesn't ask for it, and it would be weird because this is already measured in inches. So don't worry about the units there. And then we want to determine if this is greater than or less than our integral. Let's pay attention that this graph is increasing. So we have some increasing graph. And we drew right rectangles. So I'm choosing a right rectangle. Is that over approximation or an under approximation? I can see that it's over. That's because my right endpoint is smaller than my left endpoint on any interval. And so we're going to say since h of t is decreasing, or is increasing, sorry, this right approximation is greater than the integral from 0 to 10 h of t dt. In other words, it's an overestimate.